No. Oh, yeah. Oh, that's fine. And then I got this one where you have to show both sides.
First family?
She said you can read off.
As long as it sounds like natural. And
Just practice the words, yeah, or not well.
Spanish is obviously my second language.
More like my, just because I just don't know it well at all.
I like when you finish
There's a lot of problems.
textbook homework.
And I don't know why you can't just say like odd numbers 3.
Yeah, I got this. I
It's
just,
so much easier.
yeah.
It's on. What?
20 minutes early, yeah. It's that traffic, it's really getting to me. And we got like dad and the car next to us. It's close. But like it's just all my It's like right outside the school. Yeah, they have like some, oh, like this, like, wait, I don't understand what you're supposed to go. There's always more people coming out of no, wait. Like I went into the valley yesterday and all your people and he's got
Okay. Make sure you guys picked up the handout. You will also need a textbook today, and you'll also need a blank piece of paper. So take a moment to get all that sorted out. Okay, Oliver, Matt, William.
Good morning, FHS.
No, I need to.
All right. Okay, so last time I saw you guys, we started talking about the basic derivative rules, and I had mentioned to you that there's really only a handful of ways that you have to be able to take a derivative in this class. Guys, please. So some of them are memorization, and you probably saw the bulk of them already. One of them is power rule, which we practiced last class, and you're supposed to practice a little bit more of that from the bookwork. I'm not taking that bookwork up until next class, but it should be done because we're moving on from that. Taking a derivative with a calculator, we looked at once or twice. That's something we need to practice throughout the year. There's something called chain rule we won't get to till later. And then the other ones that you have to be able to do for the whole semester is something called product rule and quotient rule. So that's what we're going to practice today. And I've got a big book assignment because these take a lot of practice. We won't get all the way through it, but we'll aim for like half of it at least. So the handout you picked up should be 21. I don't remember if I numbered it or not, but if I didn't, please number it. So unlike limits, derivatives don't work the same way for multiplication and division, which is the purpose and the reason that we need these product and quotient rules. So what I'm referring to there is when we did something like the limit of f of x times g of x, we could just do the limit of f of x, get an answer, then do the limit of g of x, get an answer, and then we could multiply those together. Multiply, multiply. And then division was the same way. If it was something divided by something with limits, you could take the limit of the numerator, put it over the limit of the denominator, and it was pretty straightforward. That would be wonderful if derivatives worked out that way, but they don't. You can't just take the derivative of the first thing, take the derivative of the second thing, and then slap a multiplication sign in between them. So for product rule, we got a couple of examples here, but this is what the product rule says. If you want to take the derivative of something times something, there's a pattern you have to follow. You have to take the derivative of the first thing times the second thing left alone. I know this one's derivative because it has a prime mark. This one's not derivative because it doesn't have a prime mark. Plus, then you do it the opposite direction. The derivative of the second thing times the first thing left alone. So when we look over here, if I want to take this derivative, y becomes y prime as soon as I'm doing derivative. And the power rule, or product rule, says take the derivative of the first thing. So to take the derivative of square root of x, this is what you started practicing last time, but you actually get quite a bit of practice on it today as well. You need to write the square root of x as x to the 1/2. You would need to bring the power down, lower the power by 1. If it's got a negative exponent, you could move that to the denominator and maybe rewrite it as a square root. So I'm going over that part kind of quickly because we practiced that last class. But the derivative of the first thing would be 1 over 2 square root of x. This says times the second thing left alone, so e to the x. And then add, and then do it the other way. Take the derivative of the second thing, and the derivative of e to the x is what? E to the x, that's an easy one, times the first thing left alone. So leave it at square root of x. So technically that is the derivative. And when you have an FRQ, if the FRQ just flat out said find the derivative, that would be perfectly fine. But a lot of our work today, other than practicing memorizing these patterns, practicing taking some small derivatives like this, getting better at that, usually if this shows up on a multiple choice question, it's going to simplify it some. So how much you need to simplify it just kind of depends on the question, but this one we could at least say very quickly, if both these have an e to the x, at the very least we could factor that out. Now when we move over to the book assignment here in just a bit, I'm going to say that you need to continue to simplify until it matches the back of the book. The simplifying is not really the important part of today, but it's something that we have to get better at throughout the year. So if you are just dismissive of that and don't put in a good effort of that, then you might be able to do the product rule on the test, but you may not be able to identify which one's your answer. So again, FRQs, you don't have to simplify. If it just wants derivative, multiple choice, you usually do have to simplify. So product rule, and then simplify till it matches one of your choices. Okay, so for the second one, here's f of x. So the derivative is going to be f prime of x. And this is product rule because it's something times something. So look at this product rule and tell me what it's asking us to do first. Multiply what? Yeah. Okay, so take the derivative of the first thing. That's what they're calling f of x. And that would be what? Okay. And then somebody else.
Multiply it by g of x.
Okay, and what is g of x?
Square root of x minus 1.
Okay, so the second part left alone. And then add, and then we'll do them in the other order. Okay, what comes after that?
Derivative of g of x.
Okay, and again, I can do this a little bit quicker than you guys, but I did the same one up here. This is a real common one. Think of this as 1/2. You could bring the power down, lower the power by 1, move it to the denominator so it's positive, and then usually we rewrite it back. And the derivative of a constant is 0, so I don't need anything. That -1 doesn't change anything. And then finally the last part says this, which means what?
Just x cubed.
Okay, so just x cubed, just the first term. So after you practice this 5, 10, 15 times, you get very familiar with the pattern. Derivative of the first with the second left alone, plus, and then do it in the other order. Take the derivative of the second with the first left alone. Now, how much simplifying you need to do? Again, this just depends. When we do the book assignment, you need to simplify till it matches the back of the book. Sometimes it's very simple, sometimes there's no simplifying, and sometimes it's a pain because we have to add fractions and such. On this one, though, I think we could at least say these two obviously have a GCF of x cubed, so we could at least factor that out. But 95% of my concern today is this first one. The simplifying gets easier. Now, it may not look the same, but Harper, you started to say something a minute ago that instead of the product rule, I want you guys to know that this is always an option to you. I know the book assignment specifically says on a few questions, use product rule. Specifically on a few questions, it's going to say use quotient rule. But most of the time, if you can find the derivative, we don't care. So Harper, do you know what you were about to say before we went through this process?
I just misunderstood the question.
No, I know, but you had a good thought though. Do you remember what you were going to say?
Multiply by 2 times.
Right, so a lot of times, this is just kind of a sidebar here. If you can do algebra work or fraction work or exponent work before calculus, honestly, a lot of the times that's easier. So I think what she was going for is you could multiply these, distribute it. Remember when you multiply things with the same base, you add the exponents. So this would be like x to the 3.5. Why do you think someone might think this is easier to take the derivative of? Right, because if it's written this way, you can just do the power rule a couple times. And again, it's kind of hard to see that these are equivalent, but if you can distribute or do fractions or something like that before you do derivative, sometimes that is a smarter play than just automatically jumping into the product rule or the quotient rule. So we need to really focus on product rule and quotient rule today, but on the questions that don't specify how to do it, if you think you have a smarter play like this, multiply them first and then do the derivative, then by all means, please do, because long term, that's what we're really going for. Okay, before we move on to the other one, quotient rule, do you guys have any questions about this? Are you okay with what this pattern is saying? You feel like you can get that down after you practice it a few times? All right. Then the other one we have to do by hand is quotient rule. Again, as much as I would love to just take the derivative of the numerator, then put it over the derivative of the denominator, that's not how derivatives work with division. So we have to have this thing called quotient rule. Remember, quotient means divide. So anytime you have something divided by something, it could be quotient rule. Unless you could rewrite it and do power rule, if you'd rather. And this one's a little more intimidating, but it's kind of the same idea. It says take the derivative of the numerator times the denominator left alone, minus, and then do it the other way, minus, then take the derivative of the denominator times the numerator left alone. And then the part that students forget early in the year is you have to put it all over the denominator squared. So looking at this, I should be taking the derivative of what for question 3? Okay, and what is the derivative of e to the x? Okay, and then the next part, somebody different please. What is this asking for? Okay, and the denominator is sine x. This one's a minus sign. The product rule had a plus sign. Okay, then it wants the derivative of the denominator, which is, what's the derivative of sine? Okay. Again, that if that didn't come to you as quick as it did everybody else, it gets easier because you use them all the time. And then times the numerator left alone, which is e to the x. And then we can't forget putting all over the denominator squared. So it's a messy derivative, but technically that is the derivative right there. As far as simplifying goes, I would suspect that they would probably factor out the e to the x, but again, it just depends question by question. Sometimes we need to do less, sometimes we need to do more. But that pattern is what you'll have to pick up on as you practice it. So again, when we move over to the book assignment, lean on your notes a lot, but every time you use the quotient rule, try to look at it less. Derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, all over the denominator squared. And again, that seems like a lot, but it's really like one of like 5 or 6 ways you have to be able to do a derivative. So. Okay, any clarification you guys would like to ask about this? What this is saying? How to apply it? Then the other thing I want to squeeze in is I told you guys most of the stuff that you need to have memorized last class. That included like the derivative of sine to be cosine. The derivative of cosine is negative sine. And even though I told you the bulk of the ones that you have to memorize, I didn't tell you all of them yet. So here's the other trig identities. This one is also really important. The derivative of tangent to be secant squared comes up a lot. These 3 don't come up often, but they do come up. Now, there's some tips in memorizing these. If you notice, what is the derivative of anything that starts with a C? What do they all have in common? I'm sorry? Negative? Okay. I hear you, but my brain just... Yeah, so there's some stuff like that. If it's the derivative of a trig function that starts with C, it's going to be negative. If it's the derivative of something that doesn't start with C, it's positive. There's some tricks that you can do. But I really want to focus on this one for just a second. I hope that you don't have to do this all year, because that's the whole point of memorizing this, is you're creating shortcuts for yourself. But let's say I have had students in the past tell me that on the AP test, they didn't remember the derivative of tangent, But in whatever section of the test that was, they had some extra time. It's like the ACT. You do so many questions and then you're not allowed to move on until time's up. Then you do some more questions and you're not allowed to move until time goes up. So what if I rephrase this? This is going to pull in one of our new things. In pre-cal, how did we normally find tangent values? Okay. Sine over cosine. And don't we know how to take the derivative of something divided by something now? That's the quotient rule. So, quotient rule that we just talked about, it says take the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. Your numerator becomes cosine squared plus sine squared. And what is sine squared plus cosine squared always equal to? 1. That's the biggest, most popular Pythagorean identity. And 1 over cosine is what? Secant. So 1 over cosine squared is secant squared. So in theory, if you remember that tangent sine over cosine, and you can do quotient rule, which you need to do for other problems, in theory you can derive it and figure it out in the moment. And you could even do that with these as well, but that's not something that you have to do on your AP test, and we don't require you to do it. I just want you to know that if you're interested in deriving those, it's really not that unreasonable. Okay, so make sure you memorize this one as soon as possible, and then make sure you know these 3 also by our next test. Probably won't be a ton of questions on those, but there could be one. Okay, before we move on to the bookwork, I want to do just a couple questions of guided practice. So take just a second and try question 4. Feel free to flip over to the front page if you think you need it, or look at the top of this page if you need it. I didn't give you time to memorize the product rule or the quotient rule or these new trig identities, so use your notes. But we need to make sure that you know where to pull from at least. Just do question 4 first. Okay, you guys will have to check my work here, because honestly those other 3 trig derivatives, I'm always rusty on those at the beginning of the year, because again we just don't use them as much. But derivative of this would be 3 times the derivative of secant, which I believe is secant x tangent x. Is that correct? And then the derivative of negative 10 cosine x would be negative 10 times the derivative of cosine x, which is negative sine x, which is going to make that positive. Everybody got that? So if you have the trig identities memorized, then you can do one like that. Okay, without giving you any tips, try question 5. If that's not enough time, hopefully at least lets you emphasize where you are slowing down. So what I needed you to see is that when you did this, well, first off, with notation here, if this is y, the derivative is y prime. We need to name what we're talking about. So this 5 is going to make it 5 times bigger. So I'm just going to put that out in parentheses. But if you just took the derivative of e to the x and then took the derivative of sine and slapped a multiply sign in between them, that's not how that works. We wouldn't need the product rule if that was the case. The product rule says you need to take the derivative of one of these with the other one left alone, plus, and then switch the order. Leave the other one alone, times the derivative of the other one. Now, technically with product rule, it doesn't matter the order because addition is commutative. This plus this is the same as this plus this. 5 plus 3 is the same as 3 plus 5. On quotient rule, it has a minus sign, so you do have to be careful about which one comes first. Okay, and then this, once you have this memorized, it's going to be 4 times the derivative of cosecant, which I believe is negative cosecant x cotangent x. Is that correct? Okay. Again, I'm always just a little bit rusty there. So, once you know the product rule and pattern, and you know the derivative of e to the x already, you probably know the derivative of sine already, and then once you memorize the derivative of cosecant, you can do one like that. And again, I just suspect, you don't have to write this extra step out, but I suspect that they would probably factor out this e to the x if it was a multiple choice question. That would be some pretty easy simplifying to do. Okay, anything specific about this one y'all want to ask that I can help with? Again, if you just didn't have enough time, just try to focus in on what it was that held you up. So that's going to come up a lot. Okay, then let's try 2 more. So jump over to number 6. Take a few moments there.
Can you go back to 5 for 1 second?
Okay.
Is that not what you got?
No, it is. I just make sure. Thank you.
Okay, move on to the next part while you wait.
Next plate.
We're going to do book assignment. There's an assignment there telling you that you need to pick up a book. You brought your book? You don't have to bring your book for me, by the way. We got plenty of classroom copies. Just 1 more minute, and then even if you're not finished, that's okay. You're still getting some quick feedback. Okay, I'm gonna hope that you guys didn't do this on question 6, and you don't have to write this down, but I want you to learn from this mistake I'm about to do. When I look at this, technically this is something divided by something, so I can use quotient rule on this part if I want to. Quotient rule says take the derivative of the numerator times the denominator left alone, minus the derivative of the denominator with the numerator left alone, all over the denominator squared. 0 times anything goes to 0. This could cancel out 3 of these, and that part could come out to be negative 12 w to the 5th. So for this part of the answer, did anybody get negative 12 over w to the 5th? So quotient rule works, but isn't there a smarter way to do that? This is why there is that book assignment with the power rule. It's not that the power rule, it's not that you have to practice the power rule 20 times to get it. It's that if you recognize, hey, I could just rewrite this with exponent rules before I do calculus, you can just do the power rule. So you could bring the power down, lower the power by 1, and then move it to the other side to simplify it. So you can see, same thing, nothing wrong with the quotient rule other than, it's not very efficient. Okay, and then over here, this guy, so this is minus all of this. So when we take the derivative, it's going to be minus all of this. You're going to have to use product rule here. You've got something times something, and product rule says take the derivative of the first thing times the second thing left alone, plus the derivative of the second thing with the first thing left alone. So I would have landed on an answer of about negative 12 over w to the 5th minus, I don't know, I'd at least factor out the w something like that. Now, do I have to have these parentheses here?
Yeah.
Okay, what if I take them away? Is there any way to make it right without the parentheses?
You can do that in the
Right, so you could distribute if you did like that. So that's fine too. But if it's minus all of this, when you take the derivative, it's still minus all of that. Oh. Okay, anything that jumps out at you about that one that you didn't think to try? Or you didn't understand where I got it from? Now again, I'm glazing over the fact that like tangent is secant squared. I just have that one memorized. You guys will get that over time. But okay, then let's try one more together. Try question 7 and see how it goes. The class website that you have bookmarked in your Chromebook, and the top right, the agendas are all on there. So if you want to look at it right over, it'll be there. Okay. You guys ready to check? Okay. So again, proper notation. If this is the function, your derivative should be called prime, p prime. This is definitely something divided by something, which is my clue to use quotient rule. And then quotient rule says take the derivative of the numerator, which would be negative sign, times the denominator left alone. Then subtract, and then do it the opposite order. Take the derivative of the denominator, which would be negative 2 cosine t times the numerator left alone. And again, I know that's a lot, but don't forget the denominator. It's just as important. All over the denominator squared.
What happens to the 3 when you take the derivative of the bottom of like the g of x of the bottom?
Well, the derivative of the constant's 0, so it went away. And so then up here, I mean, I guess you could maybe distribute this, might be better. I don't know. There should be a t there though. For simplifying, we could at least say cosine times cosine is cosine squared, but realistically, that's probably all the simplifying we can do. Yeah.
If you distribute the negative sign, then doesn't that make it sine squared t plus cosine squared t?
Well, this is a 2 in front, so it would be 2 sine squareds and 1 cosine squared. I guess you could split one of these up and change the sine squared plus cosine squared to 1. I don't know that you would need to do that often, but it's good to think about. Because if what's going to happen is you guys get your derivative on a test, it's multiple choice, you don't see your answer, you got to do one of two things. You've either got to decide to try to simplify it more, or you've got to question and make sure that you did the derivative correctly, whether it's the product rule pattern or the parts of the derivatives that you need. But if you think it's simplifying, then yeah, you might have to get creative. But okay, anything that jumps out there? Yeah.
Is it possible to expand the denominator? Or should we just leave it
You
as
can,
is?
but there's really no need to. If you would rather write this as 3 minus 2 sine t times 3 minus 2 sine t, then go for it. It's just that's not more simplified. You may not, and what worries me is cancel these. You can't cancel out terms. This is being added or subtracted to something else, so they don't cancel further. So if you want to expand it, sure, but it's probably never going to be expanded on a multiple choice. And as a free response, why would you make more work for yourself? There's no need to. Okay, so let's kind of hit the reset button here. So we saw what the product rule is and when to use it, what the quotient rule is and when to use it, and 4 new trig identities that have to be memorized, especially the tangent one. Tangent one immediately, the others just before your next assessment. So on your blank piece of paper, if you want to go ahead and copy that assignment down and start it, see how it goes. So this blank piece of paper needs to be number 22 in your binder, please. And again, this is a long book assignment. I do not expect you to finish this in class. I'm not going to expect you to finish it for homework. There is a certain number that I think you should get to, just based on how yesterday's class did. But what you need to do is try question 3, check the answer in the back of the book. If it looks different, see if maybe you need to simplify it more, or maybe you need to reevaluate your derivative. But 90-95% of my concern is just taking the derivative today. We will also practice the simplifying, but don't stress about the simplifying. The simplifying only gets easier as we go throughout the year. There's just no way around of just diving into it though. All right, wasn't number 3 one that was like the answer doesn't look the same in the back?
Yeah.
Again, this doesn't happen on every single question, but okay, I thought I had it written down. Okay, so if you never thought of a way to simplify that number 3, then let's make sure you did the first part first, because again, that's the most important part. Again, keep in mind that in this long book assignment, we're really just aiming for growth here. Every time you do a couple more product rules or a couple more quotient rules, you should be needing to look at the pattern, the formula a little bit less. You should be getting a little bit better at doing the power rule quicker. You should need to look at the ones you have to memorize a little bit less. So as long as you're making progress every few questions, then you will start to get the hang of it. But at first, it's a little rusty. Okay, so in question 3, again, now technically, you could have distributed this and done power rule a couple times. Now you do have to know like what the square root of t times t squared is. But this question does say use product rule, so I'm going to do product rule, something times something. So what I suspect you guys have on your page is the derivative of this. That's the power rule. Bring the power down, lower the power by 1, move it to the denominator, rewrite it as a square root, times this left alone, plus the derivative of this with this left alone. I'm guessing that's what most of you have on your page. Okay, so let's say that this was a question on the test and none of your answers look like that. Again, this is not that common, but it does have to happen sometimes. What I noticed when I looked at the answer, gave me a hint, is that you can look at this as a big fraction and this as a big fraction. If I make these have a common denominator, I can push these together with that common denominator. So this already has the least common denominator. This guy needs to be multiplied by 2 square root of t, which means you have to multiply the numerator by 2 square roots of t. You can't just multiply the bottom by something without multiplying the top and expect the size not to change. And so over here, we've got 1 minus t squared Over here, I've got a negative 2 times 2, t times square root of t times square root of t. What is t times square root of t times square root of t? Good. Square root of t times square root of t is t, times another t is t squared. And then I think the only thing you have to do at that point is say these two are like terms. And I think that's probably how they wrote the answer. Does that look like the back of the book now? It is? Okay. So again, I'm happy that you get here. That's the most important step. But if you don't practice the simplifying, then you're not going to think of things like get a common denominator and add your fractions together. So, but I will still help with the simplifying. Okay, if you have any specifics about 3, just call me over as I come around. Otherwise, you can kind of keep going at your own pace here.
the derivative of
Yeah.
x, which is just 1. I just left that, and then I did my subtraction, and I less the derivative of x, or actually that.
Looks like you did the derivative twice. Looks like you're doing the derivative of the denominator, which would be good, and you did the derivative of the numerator.
Actually, this
So
is.
that should be good. And then right here, 1 times x squared plus 1 is still gonna be x squared plus 1. It looks like maybe you're trying to do the derivative the second time. Because the derivative of 1 is 0. But you still need a plus 1 here. And then now we can fix the other term. 2x times x is 2x. Now you can combine those because those are like terms. So 1x squared minus 2x squared should give you a negative 1x squared.
Yeah, okay, that makes
That's
sense.
what it's going to be.
When you're doing the quotient, because you're subtracting like the second, probably you have to distribute the negative, right?
If there's a plus or minus, you need to distribute the negative or the difference. If it's all being multiplied, then you don't want to squeeze another multiplication from the one.
But like say this is like for some reason like plus 3, it would change to minus 3 because it's being subtracted.
Again, as you check your answers, if it doesn't look right, try to find the mistake yourself first. Then maybe compare with your neighbors. As long as I'm not working a question on the board, I certainly encourage y'all to help each other and work through it. But also call me over and let me know. You should have a lot more questions here at the beginning. If your only issue is you're doing the derivative of the denominator times the numerator, it's gotta be the product rule is not a big deal, we just add the x, something plus something, which then you have to do the derivative of the numerator first. I think we just have to do that. Now, we're gonna leave the numerator alone.
So it's,
So you're saying it's like x times
I'm not.
Yeah. And then you move another one.
What'd you get?
yeah, it would be 1 times x is 0, x is 0, 1. So it's 1 times.
Yeah, we decided.
Alright, so what should we do? We should.
Big one and a minus x squared on top.
So, DJ, bring your x.
So you just do that. You did it in the wrong order.
Wait, this?
Well, you gotta do what you can do first.
Then you know it's gotta be push rule. Right?
Yes. Write it down. Write down what you did. Great, please.
Yeah, I did factor out c of x,
Well, actually,
but that's wrong, because you don't have the denominator.
unless the second part is negative and then it switches.
Because the denominator is 2 of x.
Okay, so let's get the numerator. All squared. So you're on the right track, and now we just need to simplify it to less the same. So 2x squared times x is what? Okay. So we've got 1x squared minus 2x squared.
Squared x. all over
Denominator is just
X
assigned.
is right here. Plus one.
Or no, it should be
Minus
via
x squared on
x,
5.
right?
I don't know.
You can't use that.
Do that one.
I'll just start.
Denominator, couldn't really do anything with it. It's along for the ride.
Cause this one's harder than the other, you know?
I think in the back, what they switch these two, they do
Wait,
one
did you
minus.
say? Yeah.
Sometimes for last 10 minutes, but otherwise we'll just go to x.
Okay, so x group,
Nine,
first,
three, seven.
and then take the derivative of adding two things. You can do it separately or not.
You look like that.
And so the
Oh,
Hey, what?
derivative of x squared. Yeah, and then the derivative of one.
Yeah, that's one more.
If you were even not side.
You see how you put the smaller fraction and the bigger fraction?
No.
So it's a complex, so you really need to multiply this. This like
So there's two x.
Yeah, it's not as bad as it sounds, but that's what you're doing. So
Starts off the
Do I just find the derivative of these?
find the derivative, one answer, and then plug in that c into the derivative.
So on this one, it's like the denominator one, so I'm multiplying these two squares of x to this right here, this, right?
Zero.
And all of that's supposed to be over the denominator squared, that's not writing.
I will write that out there.
But you're gonna forget it.
I will. But,
Mine
Okay.
what is that gonna
is
look like? I know, this word is
Part of it is if you put all of this over the denominator squared, you would see that you have a smaller fraction within a bigger fraction, which makes it a complex fraction. So you really want to multiply this by 2 squared root of x to make that cancel and go away. And then you have to multiply this by 2 squared root of x and the denominator by 2 squared root of x.
Okay.
That's how they're simplifying.
But then when I have to multiply both of these terms by two squares, right?
The 3 times 2 would be 6.
So this is just.
X squared of x times squared of x would be
Both sides.
times the next squared gives you x cubed. So that's not going to be the hard part.
Is that match from the book?
Yes.
So I got this one that got the same as Gracie.
You see?
On your quotient rule right here,
I didn't think about
what happened to what happened to your
It was
six?
x
Pieces. It's probably easiest.
You don't get to multiply that. What is x times
I
x?
think that sounds
Okay, when you multiply things with the same base, you add the exponents. So here, x to the 1/2 times x squared is an x to the first. We have to add the other, so it becomes x to the 3 over 2.
What's for, once you find the derivative, you find.
This take a lot of work.
I guess
It's
this will
very
affect
difficult
the
to
sum of that
one negative sign.
Right?
But good not to
Yeah.
rush.
So like, say this was an FRQ,
Yeah,
would it be
find the
okay
derivative
to
first.
simplify?
FRQs, you don't have to simplify at all. But I can, very rarely does the FRQ just say find the derivative.
Okay.
Usually it would be like,
Are there word problems like stat, or like no?
yeah, they're probably pretty similar. You can Google search and see related ones.
Okay.
Yeah.
Which is good, because that becomes 4 over 2 equals 2, so you end up with 1. Okay, has everyone finished trying question 9? Because I know it's a hard one to simplify. If you haven't tried it yet, I'd like you to try it first. Okay, follow along with me if you're concerned about the derivative part of number 9. And then I will tell you when I start to simplify it. Okay, so the parts that should be coming a little bit quicker is you should realize this has to be quotient rule because it's divided. Quotient means divide. You still have to look up the quotient rule every question, but you should be feeling like you have to rely on it a little bit less.
it says take the derivative of the numerator. If you're not sure why this is equal to this, you need to ask me and let me show you, because it's the power rule, but I'm doing a couple steps in my head. Times the denominator left alone minus, and then the derivative of the denominator times the numerator left alone. And I know you don't think you need the denominator for a while, but if you don't write over the denominator squared, you're going to forget to put it there. Okay, so that should be the derivative part. Again, that's my biggest concern today. Is there any questions to get to this step? Okay, the simplifying, when I look at this, I've got a small fraction within a big fraction. That's what we called a complex fraction, and we don't have to deal with these often, but luckily we did deal with them in limits as well. So with the complex fraction, I would love to multiply this by 2 square root of x, because that makes that cancel. But I can't just multiply one term by 2 square root of x without changing the size, unless I'm willing to multiply every term by 2 square root of x. So when I multiply here, those cancel out and leave an x cubed plus 1. Over here, this looks really nasty, but it's really not that bad, because you've got a 3 times a 2, which would be 6. You've got a square root of x times a square root of x, which would be x, times another x squared, which gives us x cubed. And then the only other thing you can do should be to simplify those two, because they're like terms. So I would say like 1 minus 5x cubed over all of that stuff. Is that what the back of the book did? Or is that how far they got? So I suspect it was probably the complex fraction. The one thing that you can do to make it a little bit easier for yourself, some of you guys write so small that it's hard for you to see, and like when this is a small fraction within a big fraction and you're cramming all this into 1 or 2 tiny lines, it's really hard to keep up with what you're doing, and it makes it a little harder to see. Take up more space, use an extra piece or 2 of paper on your assignment in the end. I really think that that will pay off for you in the long run. But if you have something more specific about 9, just call me over as I come around. Again, I promise they're not all that bad at simplifying, but if we don't review these things as they come up, then we won't be able to do them all over.
I did the pattern, but then,
Okay.
yes, what do you got for that? I feel like I'm all
My guess is that they're probably going to distribute all of this, spoil these, combine like terms. They're going to clean it up as much as possible. Now this is what I was hinting at in the first suggestion. So these say use quotient rule, and these just say find the derivative. So yours should come out right too, but some people are going to think, why don't I just multiply this up together first?
Okay, because you're gonna have to do that anyways.
Right. And if you do that first, then the only calculus you have to do is the power rule a couple times, which is a little easier than a messy product.
Wait, do you want to play?
Yeah.
Why can't you explain it?
Did you do product rule? So well, I start looking at their answer. I suspect their answer probably doesn't look like that, so yeah, they're probably going to multiply these, boil those, combine all the like terms. Now, I don't know that you should start over, but remember one thing we talked about. See, these say use product rule, these say use quotient rule, and these just say find the derivative. So what might have been more efficient is just to multiply these in the beginning, and then just do the power rule a couple times instead of doing the product rule. In the end, it should come out to be the same, but if one path seems easier, then that's what you change.
Right?
You do that.
You don't have to, it's just, I think it makes the question quicker, so less. You got anything you can help with? Do it on a copy. No, you don't have to.
Yeah. Yeah. But it works on the copy, I think.
Then do it. The solution doesn't need a copy.
Is that only
How's it going? Anything I can help with? Make it a little bit easier? So on this 13, was this the product rule that you did?
Yes.
Okay. So that's perfectly fine. What I've been telling other people is, if you wanted to, you could have just multiplied these from the beginning and then done the derivative, because then you would have just used a power rule each time, which is, tends to be a little messy, less messy than like long product derivatives. So.
I multiplied them out, and it's supposed to be, and I put and then I forgot about the GCF.
Which okay.
And then the problem is,
Well, wait, but you haven't done any, when you multiply them out, get this, you've not done any calculus, right?
oh, you need to
And you haven't done derivatives, but also if you factor out x and then do derivatives, you're back to doing product rule. So, don't factor. Whirling? Okay. Okay. Which one are you with? Okay. That's how it goes. You know how it started?
Writing down
Okay.
I don't know things.
I can tell you on this one,
Most of the forks.
a lot of people are jumping straight into product rule because it's something times something. And you can do that, but there's a lot of simplifying involved. And what I've been suggesting to people is maybe multiply them together first and then do the derivative. So if you do it that way, you only have to do power rule and substitution. But that's up to you.
Yes, these things.
Seem hard in the others yet? I'm getting better, so we're making progress. Slowly. This is one of those things you'll look back at the end of the year and you'll be like, how did I even struggle at this? You use it so much, it just becomes instant. Doesn't that okay? Check your answers as you go.
Yeah.
I will warn you on this one. A lot of people are doing product rule because it's sometimes something and the product rule works. But I think in the long run, it's easier and quicker if you just multiply everything first and then do the derivative. And then you don't have to do product rule. But both should get you to the same result, so whatever you need.
Could you do
got anything I can work with too?
No, I just want something else.
Just take the first two and then multiply them from there.
Oh yeah, I put that in. There you go. Okay. Wants two answers though, then. It wants you to find the derivative, and it wants you to plug 0 into the derivative. It wants two different things. Make sure you check that before. You have to that
So on how would you do the derivative of C? Like,
Well, C is a constant,
yeah.
so
Oh, it would just be 0.
so it's gonna be 0. Yeah. Something like 5 squared, so it's like 25, but the derivative of any constant is 0. So it doesn't even matter. It doesn't affect the rate. It doesn't affect the slope.
use the computer algebra system to find the derivatives.
What about it?
So just,
So they want you to do the. It's at a specific x value. It's at a specific x value.
no, it says use the computer algebra system. But find the derivative using technology.
Yeah, but at a specific point, it's giving you a point there.
You learned it last.
Question number 60.
60. Yeah, you just have to ignore those directions. Like, if you had a TI 89 or a TI 92, I think they can do those derivatives. Ours, the closest it does,
Is that a derivative point?
yeah, it has to be at a specific x value. So.
Okay.
The problem is, like, I think you could even maybe use an 89 on the AP exam, but since part of it's calculator and part's no calculator, they would just put that on no calculator anyway. Your calculator can do it for you, so. They make it in a way where it's not going to do the work. So. Fraction of 2, but 2x over 7 but 3 over 7. This is 2 7x plus 3 7x. So now do the power rule. This will be 2 7s, that would be 0, so your answer is 2 7s.
Oh, no, I think. Let's start another
So work fraction. So what they're doing is they're trying to avoid the quotient rule. Technically, it's something divided by something. The quotient rule will work, but quotient rule is also more work than the So they're using the fraction rule to split it apart. Now you just do the power rule. So when you do the derivative, you're bringing the power down, lowering the power by 1, bringing the power down, lowering the power by 1.
Why wouldn't this work as well? Should I give it power the 7?
I guess I don't know what your question is. Is your answer the same as their answer?
So they have do that and they split it up. I get that. I understand why would it work just to do the power over each line. It's the 7.
Because you can't just take the derivatives of the numerator and then put it over the derivative of the denominator. If we could do that, we wouldn't need the quotient. That's, derivatives just don't work that way.
Is that how people do it? Like, I still go back to solution.
You can get it if you have ADD or PhD, or like, middle title for it. I know that takes like 6 months to get it.
So just wasn't that enough people that was from.
I think they get it out really easily. It's not that-
Take the drug now.
They're gonna be tired of it also.
And you just look at
It
the
also
basic
skips
steps.
the math section. With the derivative. And then also my question is like evenly split, so there's like 5 each number, so at the end you have to like count the numbers missing.
I don't know where this is
So
coming
then,
from.
wait, they're evenly split.
Oh, you can't
That's the
put
only
that
one
into
that
this
they
guy's
have.
denominator, that would be.
So that's in contrast. And we're supposed to.
Would you pull up the video on the top of the page? And you can do that.
We're
the
not
rest of
looking
the
at
videos.
yourself, start in the
That's what
derivative
you're
of
trying to-
x is equal to this, so
So
then
it's a-
you need to go down to the level. Just like tricks like that, but they learn how to do it.
For the derivative.
No, it's just
What's the slope of x minus 3?
yeah.
So it's 1 times the numerator. I don't know why it's started with 1 and then that's just
It was
good.
on a different page. It was like a minute.
There's this homework you pick up. You need to make sure that you're careful on these participation rates. If you're missing some questions, then you can lose a lot of points. Shouldn't matter at the end of the semester unless you just make a habit out of it, but.
Yeah, there should be one.
I have a question. Do you want me to come up there?
Depends what your question is.
Wouldn't the sine of x times x be sine of x?
Is it the sine of x times x? Or is it the sine of x times x?
Sine of x times x.
Then that's x sine of x.
That's what I get.
Do a quiz as a one plus four.
You move the x to the top.
That's right here. In the quotient rule, you did this right, you did this right, but it's minus all of this. It's not just minus the first term. So you need to put in parentheses there. See that right here? This minus this equal to this. Just like this.
How does this
Yeah.
minus go to both of them?
So these being multiplied or is that subtracted? It looks like subtraction. I think these are being multiplied. So you've got a positive x and a negative sign. You're gonna make it negative or minus x sine x.
So this is like, it's, you're plugging it into pi over 4, so the sine of pi over 4 is
Okay.
times over times 6.
Would that just be?
We're not doing a trig. When you plug it in here, you're using the circle. When you're plugging in here, you just get pi over 4. You're not doing trig. That's gonna make your answer. Back to this, when we were talking about this, the second half of this, you just left this alone, we're kind of the derivative of this. So these are being times, this stuff alone times, so all that is multiplied. So I just said a positive times a negative is negative.
Wait, you're
X times sine x is x.
So you get two sets.
Wait.
I didn't have sine of x.
Well, I think
I just
I
saw simplified, or I didn't simplify it all.
I think you just did something less. If you multiply those, you get pi squared 2 over 8.
Yes.
And then I think they factor out the GC that.
Okay.
Wait.
We're all history last year.
Wait. Well, these questions have to do find the derivative on that part. You can also plug these numbers in.
Oh, okay.
You know the answers.
There's
It's
no
sophomore.
AP.
She's doing the plug in part. Okay, so wait. Why the left regular? We're just about to do it earlier.
Except like, a lot of
Easy. You were 17? Why are you coming in 5? You got about 4.
This is so much better than you.
Because
Because like you don't have to take notes.
they're so like not
You just have to be follow.
yeah, very different. Yeah.
I didn't really like that. I don't like and a lot of it was like memorizing all the like buttons on the calculator. I passed the
Oh wait,
test,
there's
but
more tunes.
Oh, are we out of 10? Yeah. Okay, so, again, I do not need you guys to finish all this for homework, but I do need you to do a couple more for homework. I need you to force your brain to think about it. So, based on what the other class did yesterday, they had finished around question 23, 25. So if you did less than that, you need to do a little bit more to catch up to everybody else. But I say as long as you've tried all of the questions up through 35, that is a good place to be for next class. Any of those questions you're not getting the right answer to, is not simplifying correctly, I have all of those worked out on my website. Videos to help you as you need it. If you don't need much help, then great. If you need a lot of help, then start moving in that direction.
So we need to finish
You need to get to at least question 35. You're going to do all of it eventually, so it doesn't hurt you to be ahead. But just to have something to do.